Hey guys, today we're doing 3.6 finding theta. So finding theta is actually working in reverse from finding exact trig values that we did in 3.4 and 3.5. So now the problem is going to be given to you where we know the exact value, which in this case is 1/2, and we're trying to figure out what angle measurement, when we take the sine of it, produces 1/2. So in order to do that, we're first going to have to start with all students take calculus. And we're going to have to determine which quadrants this sine of theta equals 1/2 could possibly be in. So if this is giving me a positive value, I want to determine which quadrants sine is positive in. So if I refer back, all students take calculus, this gives you the positive quadrants. So sine is positive in quadrants 1 and 2. So I'm going to put reference triangles in quadrants 1 and 2. So that's a possible theta, and this is a possible theta. Now sine equals opposite over hypotenuse. If I relate that to the 1/2 that I'm given, this tells me that opposite my theta must be 1, and my hypotenuse must be 2. So we want to think, well, what special right triangle has a hypotenuse of 2 and a side length of 1? That would be a 30, 60, 90, meaning that this remaining side would be √3 and -√3 to accommodate for the quadrants. And now we have to figure out, well, what could theta possibly be? So in a 30, 60, 90, what angle is across from the side length of 1? And that would be 30 degrees. Okay, our possible quadrants here are 1 and 2. We got that from all students take calculus. Okay, and now we want to figure out, well, what are those actual angles? So in order to do that, we're looking at the angle rotation. So if we start in standard position and the hypotenuse is my terminal side, I'm going to measure out these angle rotations. So my first angle would be 30. And then my second rotation, okay, would be 150. Solutions would be for any coterminal angle that ends where 30 and 150 do. They end on that same terminal side. So remember, when we write our solutions, we do 30 plus 360n and 150 plus 360n. Okay, take a look at another one. So now a cosecant. So the first thing I want to do is make sure that the exact trig value that they are providing to me is a fraction. So I'm going to put this over 1. Okay, and then I need to determine what is the ratio for cosecant. So cosecant is the reciprocal of sine, which makes cosecant hypotenuse over opposite. Now cosecant is going to be positive and negative in the same quadrants that sine is. So if we do an all students take calculus here for sine, it's going to be positive in 1 and 2, which means it would be negative in 3 and 4. So the value that I'm looking for here is a negative. So I'm going to put my reference triangles in 3 and 4. Okay, and I may as well go ahead and fill in my quadrants, 3 and 4. Okay, and then we want to label the sides of our triangle given this negative root 2 over 1. So I'm going to relate hypotenuse over opposite to negative root 2 over 1. Now, the hypotenuse here can never be negative. But that's okay. I can give an equivalent ratio that still would come out to be negative root 2, but doesn't have a negative hypotenuse. So root 2 over negative 1 is still equivalent to all of these forms, but now this makes more sense for hypotenuse over opposite. So hypotenuse is root 2 in both of these, and the opposite side now is telling me it should be negative 1. Well, does negative 1 on that side fit each of these triangles given the quadrant that they're in? Yes, because this is the negative y-axis here, okay? And these opposite sides are running in the same direction. Now, what special right triangle has a hypotenuse of root 2 and a side length of 1? Be a 45, 45, 90. Okay. So my reference angle is 45. Okay, and now I want to measure my angle rotations. Okay, so my first angle is just past 180. Okay, so we would be doing 45 plus 180. So my first angle here, I have 225. Okay, and then my second rotation, okay, is 45 degrees short of 360. So 360 minus 45 is 315. Okay, we take our two angles and we give our solutions. Okay, let's keep going. So now, tangent of theta equals 0. Well, tangent is opposite over adjacent, okay? And the only ratios that I could think of here that would give me 0 would have a 0 on top and something on the bottom, okay, some number, whatever it is. But an opposite side length of 0, so this is 0, not an O, okay? So can opposite equal 0? And the answer is no. So when this happens, okay, and I can't relate my ratio of opposite over adjacent to the exact value that they're giving me, this does not make sense. That means that whatever value is being given is not using a special right triangle, and instead it's a quadrantal. So if tangent is opposite over adjacent, we want to relate our opposite and adjacent side to the quadrantal values, which would be y and x. So in order to get a final answer of 0, we know we have to put a 0 on the top. We'd have some number on the bottom. We don't know what that possibly is going to be yet. Well, where in our quadrantals, remember the quadrantals are those 4 ordered pairs. Okay, where in our quadrantal does y equal 0? So look at those ordered pairs. Which ones have a y value of 0? Those two ordered pairs. Well, what angles are those? Well, this first one, 1, 0, well, that's either 0 degrees or 360, depending. Okay, and -1, 0, that would be 180 degrees. So your reference, you could say 0, 360, and 180. For quadrant, we're just going to say quadrantal. Okay, because it's not really in a quadrant, it's on an axis. Okay, angles, again, we say 0, 360, and 180. And then your solutions, you could pick either 0 or 360. You could give them both like that. And then 180 plus 360n. Okay, so the quadrantals are definitely more difficult. So how do we, one more time before we go on, how do we determine if it's a quadrantal? Okay, when you take the exact value that they gave you, so in this case you take 0, and you try and relate it to the trig ratio, opposite over adjacent. It does not make sense to have an opposite side equal 0. That's how we know, okay, this then has to be a quadrantal because this will not form a triangle. Okay, let's try again. So sine, opposite over hypotenuse, okay, and I want to turn this exact trig value, turn it into a ratio. So I could have 1 over 1. I could also try and have -1 over -1, but that doesn't actually make sense because I can't have a hypotenuse of negative. So that takes this option off the table. So all I'm looking at is 1 over 1. Well, neither of our special right triangles has a hypotenuse that equals 1. That's what this is saying here on the bottom. Well, again, if it doesn't fit for a triangle, then our only option must be quadrantal. So I want to stop and I want to relate opposite over hypotenuse to x, y, and r. So opposite is y, hypotenuse is r. Okay, bringing back that ratio that I created, 1 over 1. Well, r always equals 1. So the fact that r equals 1, it's not actually providing any unique information for me, because that works for every single quadrantal. So the only thing that's unique or giving me any clue of what angle I have is that y equals 1. Well, let's think of our 4 ordered pairs again. Where does y equal 1? Only in one place. What angle is that? 90 degrees. So the reference and the angle when it's quadrantal, those will always be the same. Okay, and then your solution, 90 plus 360n. Okay, one more. So, I'm looking at this, looking at my ratio, 2 root 3 over 3. Okay, so secant comes from cosine, which means that the ratio for secant is hypotenuse over adjacent. Well, this is weird again. An adjacent side that equals 3 and a hypotenuse that equals 2 root 3. So not only does that not fit for any special right triangles, it also doesn't fit for quadrantals right now. But the one thing that you want to start picking up on is that this value This has been rationalized. Okay, and I can tell that it's been rationalized when the root on the top matches the same number on the bottom. So I want to walk back that rationalization. I want to undo it. What that originally came from was 2 over root 3. Okay, so you remove the radical on the top and you place it back on the bottom. So this is going to work out for me. These are looking like side lengths for a special right triangle. So I need to figure out what quadrant to place them in. So we go back to all students take calculus. Now since secant is the reciprocal of cosine, we're picking the quadrants where cosine is positive, which happen to be 1 and 4. So I'm going to place triangles in 1 and 4. Okay, and back to this ratio that I created, I'm going to label my hypotenuse as 2 and my adjacent side, which they actually share here, as root 3. Okay, so what's our missing side? It's going to be 1 and negative 1. In a 30, 60, 90, what angle is across from side length 1? It's 30 degrees. So that's our reference. Our quadrants are 1 and 4. Okay, now we have to figure out the angles. So we're doing angle rotations to those terminal hypotenuse sides. Okay, so my first angle is going to be 30. And my second is going to be 330. Okay, making my solutions 30 plus 360n and 330 plus 360n.